Okay, so we are going to be talking about the lesson 4 summary. And the first thing that I noticed, so we're just going to use some annotation. First thing that I notice is, why are they using the square root of 7 as an example problem?
Well, you shouldn't necessarily focus on the square root of 7. I know it looks crazy and we don't work with it a lot, but remember, I think they're just trying to point out and make us remember that it doesn't matter if the coefficients in a polynomial are not rational numbers. Like, that's okay. So they picked a crazy number to try to remind us of that.
Well, I guess that's true, because they talked about, like in this lesson, they did talk about like integers, but they talked about those in a different way. Like they talked about that polynomials kind of follow the same rules as integers. Like they're closed under addition, multiplication, subtraction, just like integers are. But that doesn't necessarily mean that the values in a polynomial have to be integer values, right?
Right. So, and again, like closed means that like when you do those things, those operations on polynomials, you get another one back.
Yeah, that's
right. And so like it's important to remember what the definition of a polynomial is, right? And so I was looking here, it's like, oh, I thought that was going to look like a highlighter. But anyway, look, I can erase. So what really, I was looking here though to it's like a sum of terms that all have the same variable, and that variable is only raised to non-negative integer powers. Okay. And so it's basically like the powers, right, have to be positive whole numbers, including 0 though, but like positive whole numbers. That's the part that makes it a polynomial. Okay. And the coefficient parts don't matter. They can be other kinds of numbers.
Yeah.
But just remembering that like in order to be a polynomial, the powers, the exponents have to be positive whole numbers.
Yeah. And I agree. And then if you think about it, when we're like adding two polynomials together, like it doesn't make sense that the exponents would change to anything other than a positive whole number value, because they're not changing when you're adding. So it stays the same. When you're multiplying, right, they change, because it would be like x squared could become x to the third, but they're only going to be able to increase at that point.
Yeah, because the integers are closed under those operations.
Yeah. Okay.
Whenever we add or subtract those, I mean, well, we would be adding those exponents. Okay, but whenever we change them, we're changing them to positive whole numbers still.
So like if we could come up with like one kind of like statement, what would be like our summary statement here for this summary?
I feel like that's a lot of pressure. I feel like it would be that like polynomials give you other polynomials when you're adding, subtracting, or multiplying. And you know that because the exponents stay positive whole numbers. How about that?
Yeah, I think that's good.
I think we nailed it, Miss Mahalik.
All right.